Welcome to GE Fun Facts Online. Today we are going to dismantle the most fundamental fact of your existence. I want you to look at your hand, wiggle your fingers, clench your fist. You do not have to calculate whether that hand belongs to you. You do not have to deduce it. You simply know. The feeling that your body belongs to you seems like a solid, unshakable reality, a biological hardware fact that has existed since you were born. But neuroscience is now revealing that this feeling of mindness or body ownership is not a fact at all. It is a fragile construction. It is a neurological magic trick performed by your parietal cortex, and the magician's wand is a rhythmic pulse of electricity firing roughly 10 times per second. We call this the alpha brainwave. In this episode, we are going deep into the science of mind over body. We are going to explore how recent breakthroughs in neurophysiology have identified that the precise frequency of these alpha oscillations dictates the temporal resolution of your reality. We will look at how this internal clock speed decides whether you perceive a rubber hand as your own, whether you feel distinct from the chair you sit on, and in extreme cases whether you feel you exist at all. We will trace how these waves generate the self, how they fail in psychiatric disorders like schizophrenia, how they are being hijacked to engineer futuristic prosthetics, and how ancient meditation practices may have intuitively hacked this system millennia ago. Let us begin with the illusion of ownership. To understand how the brain constructs the self, we must first look at how easily that construction can be dismantled. We have to go back to 1998, to a landmark study by psychiatrists Matthew Botvinnik and Jonathan Cohen, which gave birth to the famous rubber hand illusion. In this experiment, a participant sits with their real arm hidden behind a screen. A realistic rubber hand is placed in front of them in full view. The experimenter then takes two paintbrushes and simultaneously strokes the participant's hidden real hand and the visible rubber hand. The strokes are perfectly synchronized in time. Within seconds, a strange sensation washes over the participant. They stop feeling the brush on their hidden hand and start feeling it on the rubber hand. If the experimenter suddenly smashes the rubber hand with a hammer, the participant will flinch in genuine fear. Their brain has adopted the plastic limb, remapping its proprioceptive map to include this foreign object. For decades, scientists knew that this happened, but they struggled to explain why some people succumbed to the illusion instantly, while others remained immune. The answer lies in the invisible rhythm of the brain's alpha waves. You see, the brain does not perceive the world continuously like an analog stream of water. It samples the world in discrete snapshots, much like a movie camera capturing frames on a reel. This sampling rate is governed largely by alpha oscillations, rhythmic electrical pulses originating in the thalamus and the parietal cortex. A standard alpha wave cycles at about 10 Hz, or 10 times per second. This means one perceptual frame lasts roughly 100 milliseconds. This time frame is critical because of something called the temporal binding window. Any sensory inputs that arrive within the same 100 millisecond cycle are fused together by the brain as a single, simultaneous event. Conversely, inputs that land in different cycles are perceived as separate events. In the rubber hand illusion, the visual signal of seeing the brush move and the tactile signal of feeling the brush stroke must arrive within the same temporal binding window for the brain to say, "These are the same event, therefore, that hand is mine." Recent studies from the Karolinska Institute have shown a direct correlation. Individuals with faster alpha frequencies, for example 11 or 12 Hz, have narrower temporal binding windows. Their brains take more snapshots per second. This high frame rate allows them to detect tiny discrepancies between the visual stroke and the tactile sensation. If the brush strokes are even slightly out of sync by just a few milliseconds, a person with fast alpha waves will notice the lag. Their brain will reject the illusion, maintaining a strong boundary between self and object. On the other hand, individuals with slower alpha frequencies, around 8 or 9 Hz, have wider binding windows. Their perceptual frames are longer. Even if the visual and tactile signals are slightly asynchronous, they still fall within the same long alpha cycle. The brain merges them, concludes this is happening to me, and the rubber hand becomes part of the body. This happens in the parietal cortex, specifically involving the somatosensory cortex, which processes touch, and the intraparietal sulcus, which integrates vision and touch. This region acts as the gatekeeper of the self. When alpha power is high in this region, it acts as an inhibitory filter. It is a top-down prediction mechanism. The brain predicts what the body should feel. When the alpha rhythm is strong and fast, the gatekeeper is vigilant. It says, the visual input of that rubber hand does not match the proprioceptive prediction of my real hand's location, so I reject it. But when the alpha rhythm slows or its power drops, the gatekeeper becomes drowsy. The bottom-up sensory data overwhelms the internal prediction. The brain prioritizes the visual information over the proprioceptive truth, and the self-boundary dissolves. Now, this mechanism is fascinating in a lab, but what happens when this rhythm is chronically disrupted in daily life? This brings us to the tragic phenomenology of schizophrenia. A hallmark symptom of schizophrenia is passivity phenomena, the feeling that one's thoughts or movements are not their own. A patient might reach for a cup but feel as if an external force moved their arm. This is a failure of agency attribution, a collapse of the mindness mechanism. Research indicates that patients with schizophrenia often exhibit slower peak alpha frequency and, more critically, phase discontinuities in their alpha rhythms. Their internal clock is not just slow, it is stuttering. Because their temporal binding window is pathologically wide or erratic, they may integrate sensory inputs that should be kept separate. For example, if they speak, which is a motor action, and hear their own voice, which is an auditory input, a healthy brain binds these instantly to conclude, "I am speaking." But if the timing mechanism is flawed, the auditory input might be processed in a different frame than the motor command. The brain concludes, "I heard a voice, but I didn't feel myself speaking." The result is the hallucination of hearing voices. This leaky boundary means the distinction between internal thought and external reality becomes porous. The alpha wave, which should act as a shield defining "this is me," fails to hold the line. On the complete opposite end of the spectrum lies depersonalization and derealization disorder. Sufferers often describe feeling like a robot, or as if they are watching a movie of their life. They look at their hands and know intellectually that these are their hands, but they feel no ownership over them. While schizophrenia involves a disintegration of boundaries, depersonalization often involves an overstabilization or locking down of the system. EEG studies have found frontal alpha wave overactivation in these patients. The brain is inhibiting too much. The alpha rhythm is suppressing the emotional and somatosensory richness of experience. It is a defense mechanism gone wrong, often triggered by trauma. The brain says, "The reality of this trauma is too overwhelming, so I will increase alpha inhibition to block the somatosensory emotional feedback." The result is a numb, purely visual existence. The self is protected, but at the cost of being exiled from the body. Understanding these rhythms is not just about diagnosing disorders, it is about engineering the future of the human body. We are moving into the era of alpha-tuned prosthetics. For an amputee, a prosthetic limb is often just a tool, a sophisticated hammer or pair of pliers attached to the body. It rarely feels embodied, which leads to high rates of prosthetic abandonment. Researchers at ETH Zurich are now developing neurohaptic feedback systems to solve this. By placing sensors on the prosthetic sole and knee, they convert pressure and motion into electrical pulses sent to the nerves in the user's thigh. But the secret isn't just the signal, it is the timing. To create embodiment, the artificial feedback must hit the brain within the user's specific temporal binding window. If the signal is delayed by Bluetooth latency or processing time, it falls outside the alpha cycle, and the illusion breaks. We are approaching a time when a clinician will measure a patient's individual alpha frequency before fitting a limb. A patient with a 12 Hz alpha rhythm has a tight 80 millisecond window, requiring ultra-low latency processors. A patient with an 8 Hz rhythm has a lenient 125 millisecond window and might tolerate a slower limb. Furthermore, neurofeedback training is being used to help amputees hack their own ownership. By training patients to modulate their parietal alpha activity via visual feedback, they can temporarily widen their binding window during rehabilitation, making their brain more plastic and willing to accept the mechanical stranger as a biological friend. This technology extends into virtual reality, which is essentially a rubber hand illusion for the entire body. However, VR does something unique. It potentiates alpha and beta oscillations. The immersion of VR hijacks the brain's top-down prediction mechanisms. This is now being used in virtual embodiment training for chronic pain conditions like complex regional pain syndrome. In this condition, the brain has a corrupted file for the painful limb, perceiving it as swollen or alien. In this therapy, patients wear a headset where they see a healthy, pain-free digital arm in place of their own. By synchronizing the movements perfectly, the therapy tricks the parietal alpha rhythm into accepting the digital limb as the true self. The brain overwrites the painful arm prediction with the healthy avatar prediction, effectively deleting the pain. Finally, we must ask, if the self is constructed by 10 Hz parietal oscillations, can we deconstruct it by altering the rhythm? For millennia, Eastern traditions have spoken of non-dual awareness, a state where the distinction between observer and observed collapses. Meditators describe this as a feeling of infinite spaciousness. Neuroscience offers a fascinating parallel here. In deep meditative states, particularly focused attention, there is often a massive increase in alpha power and synchronization across the cortex. Some theories suggest that in non-dual states, the top-down alpha inhibition relaxes in a specific way that stops filtering self versus other. In the flow state, the parietal alpha rhythms that usually define spatial boundaries quiet down. This is why a jazz musician feels one with the instrument, or a surfer feels one with the wave. It is not a metaphor, it is a neurophysiological event where the parietal boundary mechanism goes offline. The temporal binding window expands to include the tool or the environment within the definition of self. There is a paradox here. High fast alpha creates a sharp definition and a strong ego boundary, Slow, broad alpha creates a blurry boundary with potential for illusions. But coherent, global alpha creates the flow or non-dual mode. The difference between a psychotic break and a mystical experience may lie in the control and coherence of these rhythms. The schizophrenic patient suffers from a fragmented clock, while the meditator cultivates a smooth modulation of the clock. As we look to the future, we may see resonant architecture, spaces designed to entrain your brainwaves to specific frequencies. A workspace might use 14 Hz cues to sharpen your binding window for focus, while a relaxation pod uses 8 Hz to widen your window and dissolve stress. We may see the haptic internet, where latency management is crucial not just for speed, but for maintaining the sense of self across digital distances. We tend to think of our bodies as biological hardware, but the science of alpha oscillation suggests we are more like software running on a loop. We are a song, a rhythm of electrical pulses that frantically stitches together the chaotic sensory soup of the universe into a coherent story of me. This rhythm is powerful, yet fragile, and most importantly, it is flexible. Through technology or meditation, we can change the tempo. We can expand the window. We can rewrite the boundaries of what it means to be human. In the end, you are not the hand. You are the wave that claims it. Thank you for listening to G Fun Facts Online.